Forget every spy movie you have ever watched, because Hollywood has been lying to you for decades. A suppressed gunshot is not a whisper or a soft whistle. It is a violent mechanical event that still hits over 130 decibels.
That cinematic lie is a marketing masterpiece that sells movie tickets and video games. But the reality is a multi-billion-dollar industry built on high-end engineering and strict government regulation.
You are dealing with burning propellant, creating internal pressures of 30,000 psi or more. When those gases hit the atmosphere instantly, they expand at supersonic speeds, creating the blast you hear for miles.
From a strategic perspective, the cost of quiet is measured in more than just money. We are talking about massive tax, stamps, background checks, and a logistical paper trail that follows the owner to the grave.
The physics are brutal. Even with a high-end suppressor, a standard 9mm round is still loud enough to cause permanent hearing damage in an enclosed space.
Most people ignore the financial barrier to entry, where a simple metal tube costs more than the rifle it is attached to. It is an elite tier of hardware with a massive price floor.
If you are standing next to a suppressed 45 ACP, it sounds like a heavy industrial nail gun hitting concrete. It is a mechanical clatter, not a ghost's breath.
And the intelligence data shows that criminals rarely use them because the logistics of acquiring them legally are a nightmare, and the physics of hiding them are impossible.
You have three distinct sound sources to deal with. There is the muzzle blast, the mechanical action of the bolt slamming back, and the sonic crack of the projectile.
Law enforcement and military units don't use them to be silent. They use them for tactical communication and to hide their flash signature during night operations.
Exactly. It's about managing the signature so you don't blow your eardrums out or give away your exact position in a firefight. It is about suppression, not disappearance.
The investment in this technology is driven by the need for control on the battlefield. It is a tool for professional coordination, not for a silent assassin.
Think about the kinetic energy involved. You are trying to trap a miniature explosion inside a series of small metal chambers called baffles without blowing the whole unit apart.
If the engineering fails by even a fraction of a millimeter, you get a baffle strike that turns your expensive suppressor into a fragmented pipe bomb inches from your face.
The risk-to-reward ratio is tight. You gain a reduction in noise, but you gain heat, weight, and a massive increase in carbon fouling back into the weapons chamber.
That fouling leads to mechanical failure. In the dark business of high-stakes operations, a jammed weapon is a death sentence caused by the very tool meant to help you.
It is a trade-off. You trade reliability and portability for a slightly lower decibel rating that is still louder than a jackhammer.
We are seeing a surge in sales because people want the aesthetic, but they don't understand the technical burden or the legal weight of the hardware.
We are stripping away the myths today. We are looking at why silent is a dangerous word that gets people killed in high-risk scenarios.
Let's follow the pressure through the baffles and the money through the regulatory system. This is the loud truth about silencers.
Lock it in. We are going deep into the mechanics of the suppressed shot.
Pay attention to the numbers because the physics do not care about the movies.
If you think you can fire this in a hallway and not wake the neighbors, you are dead wrong.
The cost of being wrong is your hearing, your freedom, or your life.
Let's look at the hardware.
Let's see why it costs so much to stay loud.
Let's get into the guts of the machine because this is where the engineering meets the explosion. Inside that tube, you have a series of baffles, essentially metal dividers designed to divert, slow down, and cool the high-pressure gases exiting the barrel. If you don't manage that turbulence perfectly, the gas will just follow the bullet out at supersonic speeds, and you've gained nothing but a heavy weight on the end of your muzzle. The physics demand that you turn kinetic energy into heat energy, which is why these units can reach 300 degrees after just 1 or 2 magazines.
That heat is a logistical nightmare for any operator, but the financial mechanics are just as restrictive. In the United States, every single one of these devices requires a $200 tax stamp and a waiting period that can stretch from months to over a year due to bureaucratic bottlenecks at the ATF. This creates a massive barrier to entry that keeps the secondary market virtually non-existent and the primary market under a microscope. When you buy a suppressor, you aren't just buying a piece of pipe. You are entering a federal database that tracks your movement and your ownership of that specific serial number.
From a technical perspective, many overlook the sonic crack. Even if a device is perfectly efficient at capturing the initial sound, any projectile traveling faster than 1,100 feet per second creates its own miniature sonic boom in flight. To achieve that whisper effect seen in cinema, you must use subsonic components. These are heavier and slower, leading to a much steeper flight path. Essentially, you are trading off range and impact energy just to lower the sound level by another 20 decibels, which is a significant performance compromise.
And that trade-off has a direct impact on the dark business of arms trafficking and illicit use, because subsonic ammo is specialized, and suppressors are heavily regulated. Your average street criminal doesn't bother with them. They are too long to conceal and too hard to maintain. Professional intelligence services and high-tier military units are the only ones who can justify the logistics of cleaning carbon buildup every 500 rounds and recalibrating their optics for the shift in point of impact that occurs when you hang a pound of steel off the end of a floating barrel.
That shift is called POI shift, and it's the difference between a headshot and a total miss at 100 yards. The weight of the suppressor actually bends the barrel slightly downward, changing the harmonics of the steel as the bullet passes through. If you're in a high-risk survival scenario and you just slap a can on your rifle without re-zeroing your sights, you are effectively blind. You also have the back pressure problem, where the gas that can't get out of the front fast enough blows back through the ejection port, hitting the shooter in the face with toxic lead vapor and carbon.
That gas blowback is also a financial drain because it accelerates the wear and tear on the internal components of the weapon by up to 30%. You're looking at broken bolt carriers, snapped extractor pins, and a weapon system that runs significantly dirtier and hotter, requiring more frequent replacements of expensive parts. It's a classic case of the hidden cost in engineering. The more you try to contain the energy of the shot, the more that energy looks for other ways to escape, usually by destroying the very tool you're using to survive.
We also have to talk about the first round pop. When you fire the first shot through a cold suppressor, the oxygen inside the tube causes a secondary combustion that makes the first shot significantly louder than the ones that follow. In a tactical environment, that first shot is the only one that matters, and it's often the loudest. To counter this, some operators use ablative media, that's a fancy term for water or wire-pulling gel, to take up space and cool the gas even further. But that only lasts for a few rounds before it burns off, and you're back to metal on gas.
The global market for this hardware is shifting though, especially with the rise of drone warfare and 2030-era TACAs. We're seeing carbon fiber housings and 3D printed titanium baffles designed by AI to create the most efficient flow paths possible. These are high capital investments that change the follow-the-money trail from local machine shops to high-tech defense contractors. It's no longer about a simple tube. It's about fluid dynamics, software, and exotic materials that can withstand the heat of a full auto meltdown without warping or losing structural integrity.
But even with AI-designed titanium, the gas has to go somewhere. If you're using a short-barreled rifle, the pressure is even higher because the powder is still burning when it hits the first baffle. This creates an erosive effect, like a sandblaster hitting the metal at 3,000 feet per second. Eventually, those baffles will thin out and fail. And if you aren't checking your gear, that suppressor will eventually fail catastrophically, sending shards of metal into your line of sight, or worse.
It all comes down to the intelligence of the system. You have to know the mechanics, the logistics, and the law. If you miss one detail, the wrong thread pitch, the wrong caliber, or the wrong paperwork, the consequences are immediate and permanent. It's a high-stakes game of pressure management.
The aftermath of a suppressed engagement is nothing like the clean, quiet exits you see in cinema. Once the smoke clears, you're dealing with a weapon that is physically too hot to touch and a signature that has still likely alerted anyone within a 3-block radius. In a survival or high-risk scenario, the verdict on silencers is that they are tools for communication, not for total stealth. They allow a team to coordinate without blowing out their eardrums, but they don't buy you a free pass. If you fired that weapon, you need to displace immediately, because the mechanical clack and the sonic crack of the rounds have already pinpointed your general vicinity to any trained ear.
From a strategic and legal standpoint, the verdict is just as heavy. The global trend is moving toward more surveillance, not less, and the use of a suppressor in any context, legal or otherwise, instantly escalates the severity of investigation. We are seeing acoustic sensors in major cities that are now calibrated to recognize the specific frequency of suppressed shots. They don't look for the bang, they look for the specific mechanical resonance of the baffles. The financial cost of being caught on the wrong side of the law with this hardware is measured in decades of prison time and millions in legal fees. It is a high-stakes investment with a very narrow margin for error.
If you're looking at this from an engineering perspective, the future is in flow-through technology. The industry is moving away from trapping gas and toward venting it in controlled spirals to reduce that back pressure I mentioned earlier. This keeps the toxic gases away from the shooter's face and prevents the weapon from beating itself to death. But even with 2030 level tech, you are still carrying a foot of extra length on your rifle, making it harder to clear rooms or navigate tight brush. You have to ask yourself if the decibel reduction is worth the loss of maneuverability when your life is on the line.
And we can't ignore the dark business element of the aftermath. On the black market, a serialized, high-end suppressor is actually a liability because it's a hot item that's easy for intelligence agencies to trace back to a specific manufacturing batch or a stolen military shipment. In the world of shadow logistics, simplicity usually wins. That is why professional cleaners or low-level operatives often prefer disposable, improvised solutions that can be melted down or discarded without leaving a forensic trail. The high-end titanium can is a status symbol for the professional, but it's a beacon for the investigator.
My final tactical verdict: use them for what they are: hearing protection and flash suppression. If you're in a UV's the world survival situation, a suppressor is great for hunting without alerting every predator in the woods. But don't let it give you a false sense of security. You still have to account for the heat signature that shows up like a flare on any cheap thermal optic. You still have to maintain the threads so the unit doesn't fly off during a string of fire. Treat it like a high-maintenance engine. If you don't give it the respect the physics demand, it will fail you when the pressure peaks.
To wrap up the logistics, remember that silence is a product being sold to you. Whether it's a defense contractor selling a vision of the invisible soldier or a movie studio selling a spy fantasy, always follow the physics and the money. The real cost of a suppressor is the constant maintenance, the legal exposure, and the tactical compromises you have to make. Stay sharp, understand the limitations of your gear, and never trust your life to a myth. If you want to survive, you need to be smarter than the hardware you're carrying.
Check your baffles, watch your heat, and never assume they can't hear you coming. The world is louder than you think, and physics always gets the last word.
Stay focused on the data, keep your paperwork in order, and always have an exit plan that doesn't rely on being a ghost. Stay sharp out there.
Check your gear. We're out.